So this is all about dividing rational expressions. And again, we're going to start with a simple case with fractions, and just kind of recall what we remember from our fraction rules. So the three-step thing that I like to do, division is very similar to multiplication. The only difference is when you see division, you have to follow kind of the iconic keep it, change it, flip it. And I like this because it helps me remember what to do. Keep it, change it, flip it. And so let's take a look at this. So if I have this fraction 1/2 divided by 3/4, so I've got a half divided by 3/4. So I'm going to keep the first fraction, so I'm going to keep the 1/2. I'm going to change the division sign to multiplication, and then I'm going to flip it. So instead of 3/4, it's going to be 4/3. This is also known as the reciprocal. And then just like multiplication, we multiply across. So 1 times 4 is 4, and 2 times 3 is 6. And then we can reduce this fraction to 2/3. So it's very similar to multiplication. When we approach a problem something like this looks really crazy again, but if we break it down and we start factoring things, it's really not as crazy as we perceive it to be. So let's start looking at this thing, r plus 5 over 7r plus 35. I'm going to keep it, change it, flip it. So I'm going to rewrite this first fraction, r plus 5 over 7r plus 35. I'm going to change the sign from division to multiplication, and then I'm going to flip it. So it's 1 over r minus 7. Now the r minus 7 is going to be on the top, and the 1 is going to be on the denominator. So this is just like a multiplication problem. We multiply across, So I'm going to just rewrite it one more time. R plus 5. And I'm going to start putting it in parentheses because now we're multiplying it. R minus 7 all over 7r plus 35. Well, I've been looking at this denominator, and I'm starting to notice something kind of interesting. I'm noticing that, hey, there's a 7. 35 can be divided by 7, which I particularly like. And so I'm going to recopy the top, r plus 5 times r minus 7, and then I'm going to try and pull out a 7 from this thing. And what are we left when we pull out a 7? Well, I'm left with an r, and then 35 times 5, 7 times 5 gets me 35. Well, when I look at this expression here, when I look at this, I see, oh, I've got that r plus 5 here, and it's multiplied by stuff. And I see the r plus 5 down here, and that's multiplied by stuff. So let's get rid of that r plus 5. So I'm just going to get rid of it because they cancel out to be 1. And I'm left with whatever's left over. So the r minus 7 over 7. Now we've got to do one big thing, and you probably know exactly what I'm talking about. We've got to start thinking about what's going to make this denominator 0. And so I'm going to look at a few different things. I'm going to go back all the way back up to my original expression, that's 7r plus 35, and I'm going to take that, so 7r plus 35, and see when that equals 0. Minus 35, minus 35, 7r equals negative 35, divide by 7, r cannot be negative 5. Oh, look, that takes care of the situation over here where r could have been 5. So it already takes care of that for me. I don't need to do it again with the r plus 5. It already takes care of it when I do it up here with my original function. I've also got to consider that secondary thing at the top, where in the very, very unlikely event that r minus 7 could equal 0, got to do it again. So r minus 7 equals 0, add 7, r cannot equal 7. And so this is another exclusion. So my answer is here in the middle. that r minus 7 over 7, and then r cannot be negative 5, and r cannot be 7.